When you ask about something's magnitude, you're asking how big is this thing? And with vectors, you can do the same thing. We know exactly how far along the x and how far along the y this vector would propel something, but we don't necessarily know exactly how far it would propel the thing, like in a general direction, whichever direction it is. What I mean to say is, if you were to draw this out, 2 comma 3 would be something like this arrow, and we know exactly how far along the x and exactly how far along the y, but we don't necessarily know how long the arrow itself is. Well, the way that you do this is exactly the same way we've done everything else in trig, because you can see that there is like a right triangle forming right here. And so, in the same way that you can use the Pythagorean theorem to find the hypotenuse, you can use the Pythagorean theorem to find how big this arrow is. So if this is a leg and that's a leg, the x component, the y component, then the magnitude of u, and we notate this like this, how big u itself actually is just going to be equal to the square root of these two things put together, 2 squared plus 3 squared. This is just Pythagorean theorem, so square root of 4 plus 9 is equal to rad 13. And since you guys are boss estimators, you know that square root of 13 is somewhere between 9 and 16, so square root of 13 would be approximately equal to let me see. 14 would be 4, or 16 would be 4 squared. So this is probably like 3.5-ish. We should double check that on a calculator and see how close I am. But it's kind of exactly midway between 9 and 16, a little bit closer to the 16, but square root number sense. We'll see. That's close enough though. And then down here for this second one, same thing. If I have an arrow that is 3, 1, 2, 3, and negative 1, 2, 3, 4. Arrow looks something like this. And so we can just make a right triangle out of it. 3, negative 4. So the magnitude of vector v is going to be equal to the square root of 3 squared plus negative 4 squared is equal to square root of 9 plus 16 is equal to square root of 25. Perfect square because I'm lazy and I made the problem that way in the first place. Magnitude of this vector is about 5. It's exactly 5, in fact.